same slides as you, Ante. It's so funny. I was trying to think of what you guys would show, partly because I wanted to be a little bit provocative, maybe, and also partly because I was just curious the degree to which we would look at precedent. So anyway, let me just get started. Maybe I want to start by just asking a couple of questions, and I definitely don't have the answers, certainly not in like a half-an-hour talk today, but I thought I would just try to think of some things that first came to mind when I thought about air. First of all, the idea that it might produce a minor architecture, not in the sense of a small or an unimportant architecture, but in more the Deleuzian sense that it might create an architecture which is all about pure intensity, which is a lot of what Deleuze already talked about. Now that puts it at odds with the architecture that I've been more traditionally interested in, which is the architecture of let's say, photonics, and also things like surface and mass and all of these sort of more, let's say, disciplinary issues of architecture. So I'm really curious today about what the other speakers, have to say about the other end of that, which is this pure intensity, architecture of pure intensity. So a couple of questions that I had as well. How can something that infers immateriality drive the material condition of architecture? What kind of architecture can you produce when you're not dealing with materials except the material of air? Open question. Is air always going to refer to a position on sustainability and problem solving? How can you give air disciplinary relevance in 2012? What's the formal project that underlies that, if there is one at all? I'm personally a formalist, and I believe that in general, things need to have an underlying formal project. And let's say, for example, if we're to try to make this disciplinary, is there a microhistory of the window and the door that can be attributed to air? So in other words, the window and the door not just being functional apertures into a building, but also being, let's say, in history, being openings to the outside world that would allow not only light or passage, but also the movement of air. So a couple of open questions. Maybe we can get back to those later in some way. And back to the Reiner Banum from Ante. It's funny he even used the word provocation, which I thought was funny. I read this just the other day, and I thought it was an absurd statement. So I wanted to share it with you. When your house contains such a complex of piping, fluids, ducts, wires, inlets, outlets, ovens, sinks, and so on, when it contains so many services that the hardware can stand up by itself without any assistance from the house, why have a house to hold it up? And I thought that was, however provocative, I think it's actually, I find it really unproductive for the architectural discipline, and therefore very, very interesting for the architectural discipline. Now, it implies, and did imply, and did produce actually a series of projects. I think he was very influential in the 60s. And it implied two types of projects, I would say. The first were the dematerialized projects, which were very related to the utopian project going on at the time in the 60s, related to Archigram and others, where air became almost political. And the other group, the machine fetishists, which people like Richard Rogers, Enzo Piano, maybe Norman Foster and others, who were really interested in doing literally inside-out buildings, where you begin to expose the building services on the exterior, like the Centre Pompidou, which is a great building, and in that case, air being very technological, or at least the expression or the sign of technology and building services. Maybe even more so than the actual functioning of building services. And then something I don't want to talk about today, but I would say later on down the line, the issue of morphodynamics. So here are some of these, here's kind of what was going on. I just wanted to throw some things on a page of the space between 1961 and 1972, so basically the 60s, which were, I think, really highly related to space travel and things that were going on there. Just the idea that you would have to contain an environment, that you would need a contained environment to travel outside of our atmosphere. In 1961, first man in space, first cosmonaut in space. I was noticing Yves Klein blowing air onto water coming out of his faucet and talking about his air architecture, which is very interesting as well. but also proposing a kind of utopian world where there's only air and lightness, and things are almost moving up rather than down in the force of gravity. Other people, Club Laurent. Then there's the environment bubble from Banham, Peter Cook's Instant City, lots of bubbles in Archigram, of course, called Himmelblau. Also, which is an interesting example because I think that Wolf really brought that back around from a utopian approach to a much more materialist approach, and some of his work is more maybe better known now, like the Rooftop. So yeah, so here's the literally inside out building expression of the movement of air. However, of course, as most of you know, they have to go to great lengths in order to expose and leave this kind of machinery on the exterior of the building. The things are double insulated, of course, which you wouldn't have to do were they on the interior. So great lengths were made in order to be able to express the machine aesthetic. I don't think this has particularly necessarily to do with air per se, but expressing the machine aesthetic by turning the building inside out. Now, I just down in the lower right, I just wanted to sort of quote from Le Corbusier just for a minute, because I was thinking 1971 is also the same year that Firminy was begun. Of course, it wasn't completed until 4 years later, but the kind of dual, and I would say, let's say more important trajectory of architecture during the 20th century, the Corbusian meta project going on simultaneously to this. At the time, completely different approaches to architecture. One I think, having much more influence on the discipline than the other. So, again, utopian project. Today, basically dead. 2012 is not 1968. The machine, lots of issues with just the machinic and issues that I think come along with using mineral materials and sheet metal that I'll show in a second. Problem of obsolescence when you start to use machinery in the architecture itself, and what do you do with that? And so here's a statement in blue is something that I guess starts to hone in on my approach, I guess, would be that building technology is an instigator of transformation of architectural form, and that it shouldn't be expressed for the sake of itself, and if possible, keep it mysterious. And the first example I thought of, actually this morning I threw this in there, the iPod, it would be kind of horrifying or boring if there were to be a little transparent panel in the back of an iPhone where you could actually see the circuitry of how it's operating. I think the magic of the iPhone is in the fact that it's mysterious. So, I don't know how deep I'll get into some of these things. I just want to show a few projects. But I do want to say that the first group of projects are about fusing systems with surfaces, which is a work that I was doing for the last 3 or 4 or 5 years. The last 2 years, I've been doing more work that has to do with actually mass. And the way that I call that in the office is the surface to line geometry is the work that's had to do with surface inflections, creating possibilities for systems being embedded. And then surface to volume, which is work that I've been doing more recently, which is getting away from just pure architecture of pure envelope and into other issues. Now, all of that's tied together for me in terms of the idea of composite materiality, which for me has a lot to do with the new kind of tectonics that I'm interested in, which has to do with fusing and embedding and inlaying and healing of materials, moving beyond, as I mentioned before, sheet metal, componentry, fixtures, all those kinds of things, and trying to figure out how we can have a different kind of part-to-whole relationship, which isn't just about kind of piling things up or layering things together in building assemblies. Okay. So one model of that, which actually a biologist recommended I look at a few years ago in Venice, is the Eddie Karen moment in history, 600 million years ago. He said my work looked like this, and so I looked it up right away, and I was super excited to find this quote about these creatures that were going on here, that they were like sacks of mud, discs, hubcaps, and mattresses. It's just so weird. And when you read about them, you find out that they precede the Cambrian era, the Cambrian explosion they call it, which is where creatures started to get more and more differentiated with skeletal functions, so let's say structure, with vascular systems. Skin starts to differentiate itself from other systems. And so I find this actually more interesting, low tech, where things are having to do more than one thing at once. You find these leaves and these jellyfish, which have a lot of times inflections in surfaces or delaminations in surfaces, which allow things to happen. Yeah, another one of my favorites one of these jellyfish, of course, this is present day blood foam jellyfish. All kinds of delaminated surfaces and bladders and things like that embedded, but it's basically through surface. You're also starting to get volume, which is okay, so, and I know already that I have too many slides, so I'll have to skip through here a little bit. On your far left, I thought, what's the lowest tech of the low tech of architecture? So, of course, back to the Romans and their stuff that actually precedes this from Pakistan. But this is the one that people know about. The hypocausts, of course, where you run either usually hot water or hot air underneath the floor, so the earliest radiant heating. And then also flues in the walls, which they used to run hot or cold air in order to air condition their houses. Very, very low tech. Not really having much inflection or response in the architecture, however. A more recent example, Marco Zanusso's Olivetti factory, which I believe is in Banham's book, which is, let's say, a precursor to the kind of thinking where you can have something do more than one type of work, which is these duct beams. In this case, he's plugging air conditioning units on the end and expressing those. But I think the more interesting part is the morphology of these hollow beams that he's using in order to move air, but also hold the roof up. A few things that I love lines pushing through surfaces. I love surface inflection and tattoos. Starting to trace, but in a nuanced way, trace pathways through sheets of material. And again, the idea of surface to line, where lines can begin to pull out of surfaces as if out of a rubber sheet. They can embed into, they can pull off and become armatures. Oh, there it is. The bottoms, that was very... Okay. The double delamination at the bottom, double inflection, creating a deep cavity that you can run stuff through. Now, surface to volume. The octopus there, the volumetric head fading out into surface. And of course, the Barthes on the right, a very loose skin over a figure. Starting to think about the relation of skin to body, starting to think about a looseness of skin over body, and also skins which can be very razor thin and then also become bulbous. So that's starting to appear in the more recent work that I did. So here's some sketches of the surface volume. Okay, air diffusers. What do I write there? Death of the ceiling. I don't know. Oh, okay. I guess the air diffusers are killing the ceiling. You know, there's so much junk in ceilings, and I mention this a lot. And it's funny in auditoria where I speak, there tends to be an incredible amount of junk in the ceiling, so I always have something to look at. But I think that it really does imply a collage way of thinking about architectural surfaces, where you buy, you purchase, and you install. It's a different kind of assembly that I'm interested in. I'd be much more interested in again, fusing in composites and in trying to find multiple or even co-opted functionality in things. So the first project is Batwing, which is actually at this point quite old. It's trying to, again, find hollows within double delaminated surfaces. At the same time, beginning to figure out if those lines that are embedded in surfaces can also be illumination, and also larger, I don't know if you can see them here, but larger openings into the surface which can begin to allow air to come into space. So also, I don't know if you can see microcapillaries forward. Tons of microcapillaries inlaid into these surfaces as well with hot or cold water, so that when you throw air over them, it begins to heat or cool the air. There it is. There's a microcapillary. So those are embedded in there as well. There's a prototype of it. I think that I will show, I guess I'll show something. Yeah, it's really not happening. Sorry, guys. Okay, this is also an older project called Thermostrut, which begins to deal with composites a little bit more, deal with fluids maybe more than air, but to me it's the same set of issues, and how to begin to give some figuration to an otherwise known system, which is coiling in order to heat and cool water in a building envelope. So, and this is also the beginning of starting to think of building systems as tattoos. Rather than as separate systems, as tattoos on surfaces. So the black, as you may have seen in your heating system for your swimming pool, the coils on the roof of your house. This is doing the same thing. It's also so it's heating, cooling water, but it's also capturing water as it becomes yellow instead of tattoos. Another prototype called the gray water panel, which is an algae system, so you can begin to generate biofuel by running algae through these lines in this panel skin, and in between those lines, you also have cavities which can begin to collect gray water. So you can see some channels in there that are capture water, and of course underneath there as well, you have on the top and the bottom core of the structure, they're actually filled with liquids, but creating structural performance. So, come on, let's stick by this one. Sorry. Okay, well, as long as this is on there, I will just mention that, okay. The only reason why I showed this one, because I don't really want to talk about the whole project, but it does have these membranes on it, which are also double DLAM surfaces. So there's a pattern, computational pattern on these membranes. This project was done with Roland Snoops together, who you guys know. And there's a computational pattern on the membrane, which is, I think, a nice play off of air boom technology. Here you have air booms, or air beams, or booms, or whatever you want to call them, extremely over techno fetishized, I think, as an idea. But the idea that you can create structural performance by filling something with air and then maybe rigidizing it is interesting. However, we were talking about it in a much lower tech way, where you can have a membrane. You can have a membrane which is partially helped out by a rigid area of composite by these mohawks, and on the other hand, it starts to not rigidize, but it starts to support and stabilize itself by filling these double delaminations in the membrane with air. I'll show this this car. It's it's tangentially related to the topic of air, and it's funny when you have something that's so precise like air. You don't want to completely bend the presentation towards it and make it sound like your work is about air. It's one aspect, but for sure, stuff running through surfaces, including fluids and air, has been a theme for at least work up until a couple of years ago, I would say. This car, we did a car design last summer, though, however, called the semi-rigid car, which was based again on skins, which began to have things embedded within them. So, and it was based on a new idea of materiality, which is semi-rigidity, which comes a lot from thinking about new 3D printers, which have multi-materiality capabilities. And then we thought, well, what a perfect opportunity to rethink the car, which is the ultimate sheet metal object, and also if composites that hard composites. And we thought, well, what would it mean to take on the problem of the car in terms of more cartilaginous materials than rigid materials? So, history of the car, different kinds of structural frames, from the ladder frame down to the unibody and the space frame. Some bizarre qualities of the car in the unibody that you plan for the total destruction of the front and rear of the car and just trash it, basically. And on the right, you have a solution from General Motors, a very American-looking solution to pedestrians bouncing off of your hood. So you put on external airbags on the car to save people's lives, which I thought was really funny, so we thought that was related as well. Just to start the process, we thought, well, what if there's a car which has these external airbags which are actually embedded in the skin, so that you could run through a pneumatic system and you begin to stretch the skin. So that was one idea. As the car developed, we looked into synthetic cartilages and how you can begin to have something that's much more flexible in general. They could take impact, and they could also possibly be delivered in a different way than regular cars. And that this pretty rigid material like cartilage would then be almost dipped in a silicone type material on the outside in order to provide enclosure. So again, this is not really a design of a drivetrain, or really not a design of the exterior shape of a car. It's really trying to figure out what can you do with new materials and how does that affect the skin. So here's some, and you can see the way the materials are flowing together here in a different way than they would if they were a collage. So here's some sections through the car. It has not only various types of materiality, but it has these bladders inside that, where the skin gets incredibly thick and almost bulbous, which contain an algae biofuel system, which is intended to, let's say, be a provocation about generating energy on board on the car rather than sucking off external sources. And I like those sections very much. You can begin to see pockets forming on an undersurface, so there's an oversurface that goes over that and embeds these things in it. These are the algae system, the algae ponds, and you begin to see the thing. I'll show you one last animation. And this is just an idea of how could you deliver a car across the world, let's say. Many cars are being made in Asia. how can you deliver a car rather than just putting it in a container or putting it on the deck of a ship? How could you begin to fold it up? And if it's semi-rigid, how could you begin to roll it up almost like a tent and then transport it that way and then have that unfold and then rigidize it once it reaches its destination? So let me just show one last project here. If I can do that. Which is a different approach to the idea of air with not having it today. Okay. This is, by the way, a prototype that was done last summer that has to do with incredibly thin technology, starting to embed thin film, solar, and also OLED into surfaces. In this case, creating a kind of aquarium effect where you have, again, both solar and lighting in the same configuration, but very interested in starting to create aquariums in very deep spaces, which is the subject of this last project that I'm going to show you. This is the Busan Opera competition from last summer, which is not so much about the integration of particular building services or technologies into the skin. It's much more actually about a massing of a building that creates what I call an implied outer shell. So I just don't know this. Here it is. Here it is. This is an opera. It's on an island. It's in Busan. And the idea that you can have a kind of figure in the interior of this thing, an implied outer shell, meaning that it's an incomplete outer shell, but it is a second shell, and it starts to create its own atmosphere or environment between those two, the inner figure and the outer shell. And it was really a direct response to the brief for the project. They were asking about what do we do about the monsoons, what do we do about the extremely strong sunlight, all of these kinds of things. So we wanted to create this controlled atmosphere that's indoor-outdoor. Feels like an interior, but in fact is only an implied interior. So I'll just show one or two things of that, and then we're going to call it a day. So here, I'm going to show one of those actually. Okay, so anyway, so here's the piece. It's in this case. Well, you can tell it's actually all formed with a skin that has been so deeply involuted that you read it actually as gigantic apertures or windows into a space which is not closed. And then at the same time, there's a system of ornament on there which begins to create the possibility of apertures within that skin, which create a double reading of almost graphic quality and an incredible depth of space. So this is not, I wouldn't say that air is the primary generator of this. However, the indoor-outdoor quality and the civic quality of this project is something that I've gotten really interested in and is the basis for a lot of the new projects. Okay, thank you, and sorry about that.